Hello, my name is Görkem Güngör. Today I will present the IPCC 6 Assessment Report, Work Group 3, Energy Systems, Chapters 6.1 and 6.3. First, a general overview. The objectives of the section are to assess the specific individual mitigation options, starting from upstream activities from energy supply, secondary electricity generation, transmission, distribution, up to the downstream activities for final energy demand and energy use activities. And the second one is to assess the energy system mitigation options and challenges as a whole. The emphasis here is to have an integrated system analysis of energy system, taking into consideration the interactions between the energy systems and the social environments, which includes the demand sectors, their trends, and social systems and socio-political and economical systems. In chapter 6.1, there's a figure where from the 6 assessment report database, I have extracted the assumptions used for that figure. It is an ambitious pathway to 2060, aiming actually the 2.0 degrees Celsius temperature increase. But you can see that for all cases, there's an increase in GDP with some differences depending on the climate targets. And also for the population and GDP are main drivers for greenhouse gas emissions. For the net zero emissions with the increasing welfare and lifestyle of societies, the population is expected to peak and decrease in all the scenarios. And in the figure, we can see that both the fossil fuel supply is substituted by renewable energies, and also there's a reduction in primary energy supply. We can see that there's a large input from solar power to electricity generation. And for the residential and commercial and transport sectors, we have, especially for the transport sector, we have a large biomass input. We have a hydro input to electricity. The fossil input is very minimal at the moment, just to provide some flexibility in the energy system. And the main drivers are the costs and the capacity factors. Here we have example of onshore and offshore wind energy. We can see that already for onshore wind energy, the costs are in the range of fossil fuels. The capacity factor is increasing in the last decade. For offshore wind energy, the levelized cost of electricity has entered into the fossil fuel range. However, the capacity factor fluctuates. There are some reasons to this. The wind potential and the deployment are different compared to countries, and this results in differences in capacity factors for offshore wind. The emission growth and drivers. As mentioned in the other sections of the IPCC report, the total emissions, the greenhouse gas emissions rose across all major sectors. However, the growth rate has slowed down since compared to the previous decade, but still we have the highest emissions in human history. The energy system is still dominated by fossil fuels. Carbon dioxide emissions from fossil fuel combustion and industrial processes remains the largest contributor. There's a struggle for decoupling of emissions from the economy. Although there are improvements in energy intensity and carbon intensity, there is a structural shift to industry, transport, and buildings, which are more harder to decarbonize. Also, there has been a significant improvement in technology and costs. The costs for renewable technologies have fallen significantly. The advance in photovoltaic cells can be traced in part to aggressive deployment policies such as the feed-in tariffs, the tenders, the capacity support mechanisms. But there are some concerns regarding energy security, climate, and other environmental concerns, such as the life cycle impact of photovoltaic cells. There is also an electric mobility increasing with the falling cost of lithium-ion batteries, and this has boosted competitiveness of electric vehicles. On the figures on the left, we have the primary energy supply. We can see that fossils still dominate. We have a very minor increase in renewables as a share of primary energy. And on the right, we have final energy, where we can see that there is an electrification of final energy demand. However, coal, oil still dominates, coal mainly in the industrial sector and oil mainly in the transport sector. For the latest development, I took the same model, which is Remind MAGPIE. This is an integrated assessment model developed by the Potsdam Institute. This is one of the 6 integrated assessment models widely used for IPCC reports. And in this article, the assessment of problem is that the decarbonization of non-electric fuels, such as industry and transport, is harder to realize. We have the situation that there is still limited availability of carbon capture and storage technologies and bioenergy availability, depending on the constraints in countries. Only for the former Soviet republics, this constraint is more relaxed. There has been cost reduction in photovoltaic cells, wind power, and batteries, but this is expected to be much faster. Although all these mechanisms support decarbonization, this is still not enough to achieve the net zero climate target. So we need electric mobility and heat pumps, which could accelerate further decarbonization. And the article, the modeling results state that the massive electrification up to 66% of final energy by the middle of the century could be achieved with support mechanisms and climate policies. But the major assumption of this modeling study is the immediate abatement of coal, which is quite critical actually, because it is not homogeneously used solid fuels in the final energy demand. Countries such as India and Southeast Asia, they use solid fuels at a higher share compared to developed countries. And the sudden abatement of solid fuels, this means that these countries will be hurt more by this policy. For the transition in the transport sector and the industrial sector, usually these models use the logit function, where from 0 and 1, there's not an immediate shift, but there's a more delayed shift depending on the market penetration of these technologies. And you can see that in the graph, there's a massive electrification in transport, buildings, and industry. Hydrogen is critical for electrification because deploying massive renewable energy requires also storage mediums such as hydrogen and batteries. And you can see that the solid fuels eventually reduces to a minimum. But the question is, who pays the price of this transition? There are strong constraints in this modeling exercise to achieve the net zero climate targets. The price is paid by the former Soviet Union republics, who are the most vulnerable at the moment to stringent climate policies. We can see India, Middle East and Northern Africa, China. For developed countries such as Europe and the United States, we can see that the GDP losses are at a minimum. And there is a big, large footprint on the environment with increasing bioenergy use, increasing land use, increasing agricultural water withdrawal, and also the requirement for non-bioenergy water use for material demand. And this is a summary of Chapter 1 and Chapter 6.3. I thank you very much for your attention.